Hey, welcome. Today we're jumping into a part of the world you probably never see, the world of manufacturing. This is a place where a tiny, almost invisible flaw can cause huge problems, and where, get this, AI is literally learning to see perfection in a way that no human eye ever could.
You know the feeling, right? You get something brand new, you're excited to open it up, and then you see it. A little scratch, maybe a part that's just a bit loose. It's kind of disappointing. Well, that tiny imperfection you're holding, it's the very last chapter of a much bigger story that begins on a factory floor.
So in the industry, there's a technical term for these little slip-ups, a manufacturing fault. And this isn't just about something looking bad. A fault is any little thing that's off, anything that could mess with how the product works, or even more importantly, whether it's safe. And that is the core problem we're digging into today.
So, you might be thinking, why all the fuss over a tiny scratch? Well, because these aren't just tiny problems. We're talking about billion-dollar flaws that have this massive, massive impact.
Think about it. One single fault that slips through the cracks doesn't just annoy a customer, it sets off a whole chain reaction. It hits product quality, for sure. It can even make things unsafe. And for the company that made it, it means wasted materials, it means redoing work, and it costs them a ton of money and damages their reputation. It's just this huge, cascading wave of problems.
For the longest time, our main defense against these flaws was, well, us, the human eye. But asking people to stare at parts on a fast-moving line all day is incredibly difficult. Our eyes get tired, we get distracted. So now we're in the middle of this huge shift from the old way of doing things to a pretty amazing new solution.
And this slide really lays it all out. On one side, you've got the traditional methods. This is either a person doing a manual check or a simple computer program designed to spot, say, a specific line or shape. It works, it's easy to understand, but it's also what we call brittle. Change the lighting just a little bit and bam, it stops working. But then, on the other side, you've got AI. This thing doesn't follow simple rules. It learns what a defect actually looks like by studying thousands of examples. The accuracy is just on another level. The catch? It needs a whole lot of data and some serious computer power to get that smart.
Okay, so how in the world do you actually teach a computer to see, to spot a tiny flaw it's never encountered before? It's a really cool process, so let's pop the hood and take a look.
First things first, the AI has to know its enemy. And flaws come in all shapes and sizes. We're talking about everything from obvious scratches on a metal surface to tiny air bubbles hidden deep inside a cast metal part that you'd need an X-ray to even find. It could be a screw that's missing from a circuit board, a tiny snag in a piece of fabric, or even a chip on a Tylenol tablet. The AI has to be trained to catch all of it.
It's basically a 4-step training program. Step 1, you feed the AI tons and tons of images of a perfect product. This is its gold standard. Step 2, you show it thousands of examples of flawed products, with humans carefully pointing out, hey, the scratch is right here. Step 3, the AI just crunches all that data, learning the difference between good and bad. And finally, step 4, you put it to work on the actual production line, where it keeps learning and getting even smarter over time.
So here's the most important part of this whole thing. The data is the teacher. The AI is only going to be as good as the images it learns from. If you don't show it enough examples of a really rare type of defect, guess what? It's probably going to miss it. This is a huge challenge in the field. It's called data scarcity. And it basically means sometimes you just don't have enough bad examples for the AI to study. Okay, that's the theory. It all sounds pretty incredible, right? But does this stuff actually make a difference out there in the real world? Well, let's put some numbers on the board and see for ourselves.
Get this, over 95% detection accuracy. Let that sink in. That means these systems are catching virtually every single flaw that comes down the line. That's how we get products that are so much closer to perfect.
And it's not just about finding the bad stuff. It's also about not throwing away the good stuff. By linking these AI cameras up with other factory systems, manufacturers have cut down on false rejects. That's when a perfectly good product gets tossed out by mistake by 28%. That's a huge reduction in waste and a big boost to efficiency.
Now this number, 0.87, might look a little technical. It's called an F1 score. But just think of it like a report card grade for the AI. It measures how well it does 2 things at once. 1, find all the real defects, and 2, not raise false alarms on good products. Getting a score this high, especially when you're inspecting X-rays in real time on a production line, it proves the system is not only incredibly smart, but it's also incredibly fast.
So when you put it all together, the bottom line is just crystal clear. You put a human inspector up against an automated AI system, and it's not even a fair fight. The AI is way more accurate, and it works at a speed that a person just can't match. It is a total game changer.
So where is all this heading? What does this quest for perfection mean for all the things we buy, use, and depend on every single day?
You know, this quote from the research just nails it. These systems give you consistency, the same level of inspection every single time. They give you speed, and they give you traceability, the ability to know exactly where and when something went wrong. And all of that adds up to one thing: more reliable products that cost us less over their lifetime.
So really, the big thing to take away from all this is that even though you'll probably never see one of these AI inspectors, they are quietly making our world better. They're working behind the scenes, revolutionizing quality control to make everything from the phone in your hand to the car in your driveway safer and more dependable.
And that kind of leaves us with a wild thought to end on, doesn't it? We've taught machines how to recognize what's perfect. So what happens when we give them the tools to not just see perfection, but to build it? What will they create then? Thanks for tuning in.